Not sure if you remember this mean value theorem from earlier in the year for derivatives, but it seemed fairly obvious when you did look at it. If you have a function that goes from here to here, and you look at the average value of that, at some point if this thing is continuous, like if f of x is continuous, oops, and I don't know why I put the apostrophe there, continuous and differentiable on AB, on that interval, then there has to be some point C where it takes on that average, where the derivative is, it hits that average, right? Okay, there must be some C value. So this is for derivatives, what we've done before, right? Okay, I'm not going to write the formula. I'm going to say where, well, I guess we could. F prime at C is the slope, right? FB minus FA over B minus A. Right, so derivative is this average slope. For integrals, same kind of idea here. Since we just talked about this here, there has to be a value somewhere in there. If that thing is continuous and differentiable, okay? If this thing is continuous, then there has to be some value in there where it hits its average, right? Whatever the average is there, whether the function goes like this or it goes low like this, it has to hit the average if it's continuously going from that point to that point. If it goes from here to here, if it's continuous, it has to hit that average at some point. There must be some C value, okay? An X value. The way they say in the textbook, they say things like there must be some C in AB where f of x equals the average value, right? It has to hit that average value. F of C, sorry. Right, there has to be some C value where it's equal to the average. For the same reasons, right? If it isn't continuous, it could suddenly jump, right? If it goes like this and then suddenly like this, well, then it's skipped over its average value. It doesn't hit that value. There's no height of that function that's its average value. Right? If this is your bank account is like that, where it jumps like that, you have some amount of money, instantly you dump some other money in there. So let's say you're at $100 and then you're at $200, and let's say for half the year you had $100, half the year you had $200. The average amount of money you had over the year is $150, right? But since it's not a continuous function, the money gets instantly deposited. It isn't like the money slowly flows in there, right? If the money instantly is deposited, there was never a time when your bank account was 150. One instant it was 100, next instant it was 200. Whereas if you had this kind of bank account where it didn't jump like that, where it slowly or quickly trickled in, whether it's slow or quick or whatever, if the money was slowly trickling in, it has to hit that at some point. That's the difference. If it's continuous, okay, I should have said if f of x is continuous. Does that make sense? I don't know why I keep putting a dot up there. Okay, makes sense? Determine the average value of a function. At this point, all we can do with this is either use, you need that area. We can either use geometry, which is going to be pretty tough here, right? Or the calculator. So at this point, we're using the calculator to come up with the actual area. Eventually, you're going to do it with, you're going to do it analytically. So try a few of those problems now, or probably much later.